Thank you all. Hello and welcome. Today we're going to talk about Qt. Unsurprisingly, you probably are all familiar with this slogan: code less, create more, deploy everywhere. So can you actually code less with Qt? Well, I think we can all code less with Qt. It's a great tool for saving you time and saving you time processing in your mind, and for your developers. Can you create more? I've never been so productive than using Qt with any other language or toolkit. The real question is, can we deploy everywhere? The deployment, the microphone is on, I think. Is there a problem with this? Yeah, it was working before, and it's on actually. It is on. Yep, but it's not like. Yeah, I think so as well. Okay, so I'm gonna speak a bit louder. Um, the real question is if we can deploy everywhere. Deploy everywhere is really, really an important keyword in our slogan, and we're gonna find out today if we can do this. My name is Dario, and I'm gonna talk about middleware because middleware is probably the worst part where the deployment gets into the mathematics of things and kind of screws up everything we are doing about the multi-platform solutions. I'm a KDE hacker, and I'm really proud of it. And thanks. And I recently founded this company, Spirata, and we do provide services to other companies about Qt services and products. So why am I doing this talk? Well, because it's all about the platform. If we are here, and I guess you are here for that as well, it's because we believe that Qt is a huge platform to build in and a comfortable one, and something we want to preserve as a platform. And a platform needs to be extensible by its developers in the same way that we would expect from any other toolkit. So Qt has to be the single solution for every developer and every starting point. This is what the system we are trying to tackle looks like. We have a kernel. We have a middleware solution, which is usually not written in Qt and provided by the platform. In this case, I'm just writing upower and pulse, which are two of the most common middleware stacks on Linux. We have the application developer API, and we have a cloud of developers. Everything looks easy and simple. Not when we add a framework on top of it. Of course, if we are going to use the KDE APIs or the Qt APIs, the problem gets more complex. We are haggling the whole problem to a next level. And the world is not so simple, because the world looks pretty much like this. We have different platforms and different kernels. And we have different solutions for the same problem in every platform. And if we are considering the Linux case, it's even worse, because most of the times we have more than one middleware solving the same problem. And there is no guarantee that the platform the people will be developing on will have the same requirements and same features than another one. But of course, we've been talking about the Qt platform. So we do not need to care about this. We don't want to care about this when we are providing our tools to developers. This is our first selling point when we are doing Qt development. So what happens? The developer cloud is actually split between all of these areas. We have developers acting on the lower level, and we do not care about them in this case, because this kind of developers are what we call the very low-level developers hacking on the kernel and everything which sits below the middleware. Then we have the middleware developers, which are a very hot topic for us, and we will see why very soon. And the toolkits and frameworks developers, which is probably many of the people in this room. And of course, the application developers, which is our main target. So how are we going to solve this problem? The situation is really complicated, as you have seen. There is not a single solution for all of these problems. And the targets that we are actually trying to match are really, really strict about the requirements. Nowadays, we have Ruby, Python, and all of these tools which make the application development so easy. And we really need to cope up with that. And different developers have different needs. Because an application developer will never, ever think the same as a platform developer. It's a really different way of developing things, a really different workflow, and a really different set of competencies. Play QtDD12. This is something an application developer wants to do. Do you think you can understand something like this? And this is an actual function call from QtGStreamer. Of course, if I go back to my cat playing, this is not something a framework developer is interested in. Why, as I don't know, middleware hacker, would I be interested in such an ease of use? I don't care. I care about having full power on the API and doing the most out of it. What are the results? A single API does not fit. And this should be obvious to everyone here, because you cannot expect to solve a single problem without a different set of solutions. Because as we said, our targets are so different that we cannot really use the same way for fixing their problems. And can't I just use the lower layer? I mean, we have seen before in the diagram that there are APIs for the middleware. Again, we are talking about a platform here. And I really believe that if we want to have Qt as the main solution over this kind of problems in the next year, we need to create an environment in which all the developers can feel at home and fit. So give choice, do not force. We need these developers to be given a choice on how to create their own workflow. And we do not need to force them into doing stuff our way. What are the solutions then? I'm going to try to present you a case. It's named KAuth. It's a library I've been developing together with a Summer of Code student, which is basically this. It's a privileged escalation mechanism for Linux and an authorization library, which is based atop of different platforms. One of them is PolicyKit on Linux. It uses authorization services on macOS and user account control on Windows. So it's a great example of what we're going to showcase today, because it is exactly the answer to the previous diagram that we've seen. Now, you're seeing this window, which is probably the most user-visible thing of KAuth, but in reality, it's just a framework for developers. What problem does it solve? Basically, when we started KAuth, there was no way for having a root control module without escalating to root and starting the UI as the root user. What we wanted to do was having an authorization part in a userland space, which was capable of calling a different helper, running as root, and of course authenticated and secure, and basically avoid any kind of UI running in the root space. The problem is exactly that. And the solution is a child of this problem. So we have the Linux kernel. I intentionally simplified this problem to the Linux part because, as you see, it's already quite hard. And from the Linux kernel, we have two different middlewares. The first one is PolicyKit. The second one is Polkit1. Now, the names are really similar. You might ask yourself, why? Well, because Polkit1 is the next version of PolicyKit. But they are completely ABI and API incompatible. And most of all, they cannot coexist. And I'm not over yet, not over yet. There is more. Half of the distributions were using PolicyKit. Half of the distributions were using Polkit1. And there is more to this. Both of them exposed a dbus interface, which was used by the G-object bindings, which were completely different and written in two different ways, which were completely incompatible one with the other. One of them used G-object introspection, the other one didn't, if I recall correctly. So the situation is a bit confused, I will say. And what does it bring us to? What about the developers? Do you want to support a new framework? Lose compatibility. Everything which is actually based on PolicyKit is not going to work anymore. You want to support the old framework? Rewrite code later. And most of all, lose compatibility because some people already catched up. So, I mean, are you using Qt? Take a good laughter. Because there is no way you can actually fit Qt in this problem. So, we decided, okay, let's higher the bar. Let's support both. We do not want developers to rely on a platform which is completely burning and it's not guaranteed that it's not going to change in 2 years, because the change between PolicyKit and Polkit1 happened in the range of 6 months. So it is really something quick and fast, and we could not even keep up as KDE developers. So let's just provide developers with an API which is abstract enough to make it work. This high-level API looks pretty much like this. We generate an action, and we execute an action. Couldn't be easier, right? So we just have our helper name, which is my.own, and our action name, which is action in this case. When we create the object, we simply execute the object. This call triggers a mechanism which talks to the dbus interface of Polkit or PolicyKit1, and basically starts an helper, which through another communication API, which is internal, translates back the message to the user space. So this way we can communicate between the two processes in an authenticated way, and the operation should be secure. But this is something which is being taken care of by PolicyKit and Polkit1. It's very easy to use, as you can see. 2 lines of code and you get a full escalation mechanism, including the UI. But it's tailored around a specific use case, which is the one of control modules. If I want to create an application which executes a small chunk of code as root, I can use this. I don't see any other use case for this. But the reason behind all of this is that when you are using a solution like this for escalating privileges and authorization and the authorization of users, it is really hard to see a different use case for an application developer. And I challenge you to find another use for such a framework for a high-level developer. Figure somebody who's developing an Android application. But of course, if I'm developing a client like the one you've seen before, so the authorization dialog, which is part of the system, this is not sufficient at all because it doesn't even think about covering this case. It actually doesn't have to fix this case. We should not expose these details to the application developer because we're going to scare him away. If people are starting to see huge functions, huge chunks of code with specific names and strange parameters which doesn't make sense to them, they're going to just run away and say, well, why did I run away from HTML5? Why am I here? Why am I even doing this? So we should really prevent them from even saying that. So we did something. We bound twice. This is the situation in a more optimistic world. We have three platforms. Our middleware stack, which is different for every platform, dbus, and KAuth. You would expect that everything was developed this way, but it wasn't. We did a first set of bindings before going to the real solution for the upstream developer. We've been developing PolkitQt and PolkitQt. These two libraries were born with the purpose of exactly fixing the issue of providing the platform developers with something they could use. And this is exactly what we want to target. The platform developers, in our case, which is very specific here, were just meant to develop a set of clients, which were specific to Linux. And you might think that this is kind of overkill for just developing an authorization dialog, but it doesn't really stop there. For how holistic it works, you can develop a custom authorization dialog for every appliance, depending on your needs. This means that your application, if it needs to, can build its own authorization stack and bypass the policy authorization dialog by providing something custom. So if you want to require the user password in a, I don't know, a line edit inside your main widget, you can do this. And you can do this exactly with those libraries. But of course, this kind of use case is not really the use case that the average developer will ask for. But you can do it now. And basically, we call this Qt bindings. Qt bindings are pretty much what KD frameworks is all about and what the Qt solutions part is targeting to resolve. We have several middleware components which have been bound by Qt and are now usable with all their features in a very easy Qt-based API compared to the native platform API, which might be GObject, might be Windows Forms, might be macOS and Objective-C, or you call it even Python. And of course, they are not needed on all platforms. If we get back to this diagram, you will notice that there is no reason in this case to bind UAC, for example, because UAC doesn't allow you to do anything more than what KAuth allows you to do. You cannot build on UAC. And the same goes for auth services, because the platform, which is Windows in this case, already provides you with all the tools for client development. And there is nothing you can do about it. So in this case, the bindings are really specific to the platform. And they cannot be abstracted. We are forgetting the abstraction part here. And this is also the reason of my subtitle of the presentation. You usually focus on abstraction when you talk about middleware. But the next step is realizing that abstracting cannot be possible in most of the cases. And you don't want to abstract most of the time. You want to bind. You want to provide the same API in a different form, which is more familiar to the developer. You want to abstract in a second phase, which is the one of KAuth. Platform developers do not want abstraction. And this is something we have to accept. If you go and talk to a senior developer acting on, I don't know, Qt platform for a Raspberry Pi, and you talk to him about abstraction, he will say, yes, I can do abstraction, but don't give me a library which takes away my power. I'm using Qt and C++ because I want power. And this is the reason why I do this. So why are you depriving me of my first use case for Qt? We do not need to cut away features in this case, because there are people who need features and there are people who don't. In fact, they actually don't need abstraction, and that's the trick. But it's really useful also for high-level APIs, because one of the prerogatives for our previous diagram, in which KAuth was sitting on top of everything, was that the developer of KAuth We would have needed to know GObject, Objective-C, C++ plus Microsoft event loops and stuff. But in this case, we can reduce the fragmentation of the code because most of the bindings that we have been doing in the GObject part are now hidden beneath a Qt stack. This means that I can be very skilled, for example, in developing APIs and exposing these APIs to developers, but maybe I don't know anything about GObject. So I will be unable to work on KAuth alone. But in this way, we do not need to be familiar with different toolkits because the framework developer can already act on something he really knows. And studying the framework is really different than studying a new programming language or a new toolkit. This is all done for improving teamwork. In fact, a great demonstration of all of this is that I was basically writing the first policy kit bindings, and I've been doing all of this alone. When KAuth was born and more interest was raised, the Polkit1 Qt, binding was actually written by a different person. And what I did was just taking the new middleware and integrating into KAuth. 2 days of work. This kind of make you realize how this can be important for delivering the product on schedule. And in a commercial environment, this can be even better because you can have more specialized resources working on what they really want to do and what they really know to do, and have everyone be productive 100% all of the time. So let's take a look at it again. We said that the middleware stack is something we do not want to deal with directly. We want to bind first, and this is where our Qt bindings come up, and like give these bindings to platform developers who are gonna develop the real user space, developer space, let's call it like this, binding later, like KAuth. Let's talk about a different multimedia. Now you already see all people using Linux shivering. This is the best of the world we have now. If I were to do this presentation a couple years ago, probably I would have needed another screen for adding up to the whole mess of the Linux audio stack. But luckily now there is GStreamer, which is something which already abstracts the multimedia handling on Linux, Mac, and Windows. So we are kind of luckier than we used to be. GStreamer, we took exactly the same approach. And it's an interesting story because this approach was taken after having taken the wrong decision. Initially, Phonon, which is the Qt solution for multimedia together with QtMultimedia and the preferred one in KDE, used to be something pretty much like this. A binding to different layers. So different multimedia systems. And what we used to do was cutting off the GStreamer part, the QtGStreamer part. So we used to bind GStreamer previously, but we didn't consider the fact that GStreamer is an extremely complicated beast. GStreamer is as much powerful as it is complex. Maybe it is even more complex than powerful. And it's really easy to handle. And I guess people laughing here have been using GStreamer, right? Anyway, this kind of mistake was one of the key factors in having Phonon out of the loop at some point in Qt. The history of Phonon is kind of travailed, and maybe some of you know the relationship between Phonon and QtMultimedia. But Phonon had two main problems. The first one, the fact that the backends were not up to date and were not up to speed with other solutions. The second one was exactly the fact that people didn't know how to bind to these specific toolkits. I mean, you cannot really afford the fact that a Qt developer doing an abstraction API like Phonon, which is something incredibly complex and requires a lot of work for being done, can also mess with the backend part. And most of all, they would have dealt with GStreamer, which is in GObject, VLC, which is C++, mPlayer, which is a C, if I recall correctly. They've been trying to bind to everything, and none of the backends in the end worked correctly because nobody was really focusing on interacting with the backend in the right way. And of course, when the goal is empowering developers, it is really hard to give them an API which does only playback. So we were left with people who were not able to develop custom multimedia programs like audio editing stuff without the aid of the middleware framework, without the binding, and people who were just doing play this sound, and sometimes it didn't work on the user space. Now, the multimedia developer, of course, sits here, and the application developer sits on top of Phonon. What we did recently was to write a new backend using QtGStreamer. QtGStreamer is exactly the binding I was talking about before. We basically took one guy who was a GStreamer expert and a Qt expert at the same time, lucky chance. And we told him, well, why don't you simply develop a binding for GStreamer? Because it's going to make everything so much easier. The result was that the GStreamer backend started to work, and now it's pretty much the standard, together with the VLC one. And the VLC client is exactly the reason why I am sure that this approach works. The VLC backend has been the primary Phonon backend in use for the last year or two, I think. Well, there is only one reason for this, because VLC already exposes a binding to itself in a language which resembles Qt. It's a, if I recall correctly, it's an event-based C++ API. I might be wrong here, but I'm pretty sure that it's C or C++, without GObject boilerplate on it, which is extremely hard to integrate into Qt. The integration of GObject is something that you really need to know how it needs to be done for being done correctly. So it's kind of unsurprising that VLC, which was the most Qt-friendly interface, was actually the choice of Phonon in the end. And this was beyond technical merits, because GStreamer can do really more than VLC does, especially when you're dealing with recording. But on the other hand, it was the easiest solution. And nowadays that QtStreamer exists, actually the whole world kind of turned around, because now we have a pure Qt solution for doing complex multimedia. So we can create sinks and paths in Qt, and we can actually expose the full power of GStreamer to our multimedia developers. Because we do not have to forget the fact that people are sitting here, but our main target is here and upwards. When we want to deliver a platform to a customer, a client, or a user, we want to build on top of what we already have, because we do not want to duplicate the effort. And this is something really important and on which I'm pushing the bar a lot, especially in KDE. And we want the platform people to stay with us. We do not want to tell them, well, Qt is not your realm. Qt is just for playing games or doing small applications, because Qt is extremely more powerful than that. Hence, giving more choice is the way to go. And I really believe that this can really turn the cards on the table when you're talking about this with customers and different users. Because your audience becomes wider, and basically your influence on the market and on the platforms you're targeting becomes higher and much, much better. And simplify. Because in the end, we simplified a complex situation by adding components. It looks like a paradox, and in part it is. But if you go at the end of the tunnel, you will see that the code produced by the binding plus binding approach is actually much less than the code produced by the single binding approach. And this is pretty obvious. When you're dealing with two different levels and you need to do sort of a bridge between two programming language in the middle, you really lose track of what you're trying to do. And you really start adding boilerplate for making all the connections and all the interaction work. And if you've been working with GObject or any other different language like integrating Python solutions, you already know this way better than I do. And again, we want to have Qt as our platform. I really believe that the future of Qt stands in a position where we can say that stuff is built on Qt. And when I'm saying stuff, I'm saying everything which sits on top of your kernel. And what I see for Qt in the future is a low-power board with a Qt API on it, and somebody who tells you create. And when I'm telling you create, I'm giving you all the tools for building everything you need to have a full appliance running, be it mobile, be it a desktop appliance, be it anything else. And KDE is really pushing the bar in this regard with frameworks part. We are already working towards giving developers a set of frameworks and tools to interact with middleware in a completely multi-platform way. And of course, Qt is a platform, because we are also giving the tools to interact with the single middleware components in frameworks. Polkit1 and Polkit-Qt1 are part of KDE support. They are pure Qt libraries which do not depend on any of the KDE libraries at all. And they are designed as a pure Qt solution. So, after all of this, can we really say that we can code less? We said yes. Can we create more? We said yes. Can we actually deploy everywhere? Well, my answer is yes. And I think that we have to strive for doing this. But sometimes I really do not think it's really convenient. And as much as we want to be multi-platform and tackle all the problems that this complicated world tricks us with, we want to provide the choice that people expect us to provide them. And when we build a platform, we need developers. And developers are just not at the top of the stack, but are spread across all the levels. And we want to catch everything which sits on top of us. Deploy everywhere, support all that's needed. If I were in charge of Qt, I probably would add this fourth sentence, because I really think the future of Qt is doing exactly toward that. And we want support for all that we have. And this is pretty much everything I wanted to tell you about. So I will be the first one asking you a question. What do you think? Does it fit your use case, and can you find something which works with all that I've said? This is not a MacBook.